Hey everybody, we are going to look a little bit more deeper into area of shapes. I'm going to call this part 2, application. So last time we were just really focusing on the formula and making sure we knew which formula went with which shape. I still have my formula chart here, so I'll keep referring back to that. Hopefully you have that as well. But we're going to look at problems where it's not quite as straightforward what we have to do. Okay, so we're just going to go straight into example number 1. We are going to be given a triangle that looks kind of like this. It's going to be an isosceles triangle. So these sides are both going to be 30 centimeters, and we'll have a base down here of 26 centimeters. Okay. So step 1 is to obviously recognize that it's a triangle. So we're going to use our formula for area of a triangle that we used last time. A equals 1/2 BH. Okay. So when I look at my triangle now, I do not see a right angle anywhere. Remember we said that in order to have the base and the height, they had to make this right angle to each other. So I'm actually going to draw this line in straight down the middle of our triangle from up here at the top, and usually it will be drawn as a dotted line because it's not actually part of the shape. Okay, so when I draw that in, the question is how long is that piece? Okay, so what's happened is that when we get down here to the bottom, do you see how this came straight down the middle since these two sides are the same? If these two sides are the same, this comes straight down the middle. So what's going to happen to this 26 down here? Right here, yeah, it's going to get chopped in half. So we're going to have 13 over here on this side and then another 13 on the other side, right? Okay, so now we can take 1/2 of this big triangle, pretend that we don't have this stuff, and now we can use this 30 and this 13 to solve for this missing side by using our friend, the Pythagorean theorem, right? A squared plus b squared equals c squared. So again, our little shortcut that we did in class is we square both of the numbers. So we have this long side here of 30, we have the shorter side of 13. We square both of them. So if we're trying to find this middle side, do we want it to be bigger than the 30 or smaller than the 30? So smaller, so we're going to subtract, and then we put a big square root over the top of all of that. Okay, and once we do all of that, that's going to give us our height. Okay, so I'm going to go to my calculator. Okay, and again, if you have this kind of calculator, you're going to turn it sideways, and it will bring up the little square root thing. So we're going to do the square root of 30 squared minus 13 squared, and that's going to give us 27.04, we'll say. Okay, 27.04. I would not round it to 20. We want to probably give it a couple extra decimal places as we're working so that we are not too far off our actual answer. Okay, so that tells us now that this question mark right here is going to be 20.04. Okay, so now we've got that right angle. So we have this piece, which is the entire base of our triangle, and this piece down the middle that is our entire height. Okay. So again, we're going to use all of this, the whole 26 now, because we're not just doing half of it. So we're going to have 1/2 times, oh wait, we changed this to 0.5, right, when we were typing into our calculator. Let me go ahead and do that. 0.5 times a base of 26 times a height of 20.04. So I can type all that. Let's see. Sorry, I'll go underneath. 0.5 times 26 times 20.04 gives me an area of 260.52. And I didn't put my labels in here like I did yesterday, so this was 26 centimeters, and 20.04 centimeters. And so when we have both of those, we're going to get centimeters squared as our final answer. So if you don't want to write in those centimeters, just know that you're going to put centimeters squared or inches squared or whatever onto your final answer. Cool? All right, so one more kind of like this. I'm going to do a shape that kind of looks like this. Sort of like that. I love this graph paper notebook. It's really cool. It makes me happy. Don't be jealous. So we got 19, 10, 10, 7. And we're going to try to find the area. All right, so what shape is this? Not that, not that. Oh, kind of looks like this. So this is a trapezoid. So we are going to use our formula 1/2 b1 plus b2 times the height. Okay. So which of these pieces are going to be the bases? The two pieces that are parallel to each other. So this is base 1 and base 2. It doesn't really matter. I usually, again, usually put the little one as base 1 and the bigger one as base 2, but it doesn't have to be that way. Okay. So does that make this 10 the height? Can we have a height that is slanted like that? Nope. The height is going to be how far straight down between this top piece and this bottom piece. Okay, so I don't really want to draw it right here in the middle. That's probably not going to help me at all. So what I want to do is I want to take one of these other corners of my shape and I want to draw it in from there. Okay, so this is going to be the height. Do I know how long that piece is? Do I have that piece anywhere else across my shape? No. Do I know how long this piece is right here? I don't yet. I know that all the way across the top here is 19. So I know this is part of that 19. I just don't know how much. Okay, so I have to do one other thing here on this trapezoid. Okay, I'm going to draw the same height over here on this other side. This is still my height. But do you see how that cuts off that same piece? Do you see how these two triangles here on either edge are exactly the same size? Okay. So we're going to figure out how big this piece is now. This is kind of cool. It's almost like magic, but not quite. Okay, see this little bit right here that we're chopping out of the middle? How long is that piece? You see how it's the same as this 7 down here? So this little piece in the middle that we're chopping off is 7. So 19 minus 7 is 12. So these two pieces that my fingers are covering up together make 12. This is the rest of that 19. Well, how many pieces are there? And they're the same size, so each one is going to be 6. So this piece right here is 6, and this piece right here is 6. And together, all the way across, 6 plus 7 plus 6 adds up to 19. Okay? So now we should be able to find the height. So if I cover all of this stuff up, you see this little triangle right here that I have colored in? We're going to use Pythagorean theorem to find the missing side on that. So I've got a 10 squared and a 6 squared. Do we want this side to be bigger than 10 or smaller than 10? Smaller. And we'll put a square root over the top of all that. So the square root of 10 squared minus 6 squared equals 8. So this height is now going to equal 8 on either side, or wherever you want to put it. So now I know the pieces that can go into my formula. I really just need one of them. So I've got this 19 across the top, I've got this 7 across the bottom, and I have this 8 for the height. So those three numbers will go into my formula. 0.5, base 1 is 7, base 2 is 19, height is 8. So 0.5 times, actually I'm going to do the parentheses 0.5 parentheses 7 plus 19 times 8. 104. And then we need a label on this. So what kind of label do we have here on our numbers? There are not any, absolutely. So what do I write? Units squared, or U squared for units. Awesome. Okay, cool. All right, so we're going to switch gears just a little bit. We're going to look at some scenario or some word problems. I know those are your favorite. Okay, so on this first one, I'm not going to write out the whole word problem. I'm just going to kind of summarize it for you. Okay, so on this first one, we're going to be given a parallelogram. Oops, that's not how you spell it. Parallelogram. And on this parallelogram, we're going to be told that its area, A for area, I'll write out the whole word, area is 160.5 inches squared. Its height is 7.5 inches, and we are trying to find its base. Okay? Hear my dog? Today's my doggy's birthday. He's 4. And a punk. But that's okay. Oh, yes, baby. There's a cat outside. Okay, so what is our formula for area of a parallelogram? Area of a parallelogram is parallelogram base times height. Okay, so we're just going to take these values over here and we're going to plug them in for what we know. So this 160.5 is area, so which letter in our formula is that going to go for? Yep, that's going to go for A. What is this 7.5 going to go for if it's the height? That's going to go for H. And base is the B, so that's what we're going to solve for. That's going to be our variable. Okay, so I'm just going to replace them directly underneath my equation here. So A is going to change to 160.5 inches squared. Base is B, we don't know what that is, and that's times 7.5 inches. Okay? Alright, so one of two things. Okay? If you would like to go to an equation solver on your computer, just Google equation solver, and there are several choices to pick from. Some are easier to use than others. You can kind of mess around with it. You can type this equation. You probably won't type the labels into your equation. We'll deal with those later, okay? But you can type in the numbers, 160.5 equals B times 7.5, and hit enter, and it'll give you an answer, okay? Or we can just do it by hand. To get rid of a multiply by 7.5, we're going to do the opposite, and we're going to divide by 7.5 inches on both sides, so that 7.5 and the inches goes away. Over here we'll have 160.5 divided by 7.5, which makes 21.4. Inches squared divided by inches, this is like 2 inches, right? Inch times inch, and this is 1, so that's going to cancel. Okay, we won't have 2 on the top anymore because we're getting rid of one of them. So our answer is just going to be 21.4 inches. And this is going to be the base, or B. Okay, so just a reminder, base and height of our shapes are always going to be in inches or meters or centimeters or feet or something like that, which is one-dimensional, meaning you could draw it like this, like a straight line. Pretend that's straight. Okay, that's inches. As soon as it becomes area, that's 2-dimensional, and it would have inches squared or centimeters squared or whatever. Okay. All right, number 4. Let me move this a little bit. Okay, 4, we're going to look at a trapezoid this time. We're going to have one of the bases as 23 kilometers. Another base, we'll call this base 1 and base 2, is 29 kilometers. The area is 390 kilometers squared, and we're trying to find H, or the height. Okay. All right, so step 1, we're talking about A for area. So we need the area formula for a trapezoid. So we write all of that down. And now we're just going to plug in the numbers that we have. Okay, so I'm going to start here. Instead of starting with this, I'm going to start here. Do I know a number for A, for area? Yes, that's this. So right underneath here, we're going to put 390 kilometers squared. And then I have the equal sign. And then we're going to change the 1/2 to a 0.5, or you can leave it as 1/2 if it makes you happy. Leave the parenthesis. What do we know about B1? One of our bases is 23 kilometers plus the other base, which is 29 kilometers, and then H is what we don't know. Okay, so again, if you want to type this into an equation solver, that's cool. Just leave off these kilometers as you type it. Type, you can get an answer. Okay, but if we do this by hand, we're going to do parentheses first. So 390 equals 0.5. 23 plus 29 makes 52. And then we'll do half of 52. 52 divided by 2 is 26. So 390 kilometers squared. It's easy for you to say. Times the height. And then if I want to get rid of this 26, 26 times what value is going to give us 390. So to undo multiply by 26, we're going to divide both sides by 26. 26 divided by 26, kilometers divided by kilometers, leaves us with just H by itself. And over here on this side, 390 divided by 26 makes 15. And kilometers squared divided by kilometers is going to give us kilometers for our height. Okay, and if you wanted to double check, you could go back and plug that 15 in right here and do like half of 23 plus 29 times 15 and double check and make sure you get back to the 390. Okay, awesome. Okay. 2 more. We're going to do one with a circle, and then we're going to do one that's a true application problem. Okay, so on this one, we're given a circle, and we would like to find the diameter of this circle if we know that the area is 380.13 meters squared. Okay, so A for area. So area of a circle is this formula right here. A equals pi r squared. So we're going to write that down. I promise the people that write the formula down and then plug the numbers in are going to be more successful than the people that try to do it in their head, because that's crazy and hard. I don't like to do it. Okay, so what do we know about A? A is our area, so that's this number here, 380.13 meters squared. Pi is just a number, so we know that. That's on our calculator. And we don't have any value for our radius, so we're just going to leave that there. Okay? All right, so again, you can type this into your equation solver. Leave off this. Leave off your label. Okay, so 380.13 equals pi r squared, and it'll solve for r for you. Okay, but to undo, we're trying to get r by itself. So we got to get rid of pi first. So we're going to divide both sides by pi. And that will leave us with r squared over there. And 380.13 divided by pi. If you don't have a pi button, you can use 3.14 if you want to do that. See, my answer here is 120.999. So that's basically 121, right? If you want to divide by 3.14, it gives you 121.0 something. Okay, so we're going to use 121. Meters squared divided by, well, pi is going to have a meters on it, right? well, no, it won't. This is still meters squared, I guess. Meters squared. Okay, so how do I get rid of squaring a number? The opposite of squaring means what number times itself makes 121. So that's going to be 11, right? Or you can do this, square root of both sides. The square root of 121 is 11. Meters squared, square root, this just gets us back to meters. Okay. And again, for radius, height, diameter, base, any of those things are just going to be your units without the square on it. Okay, so is this our answer? Yay, we just got it wrong. What is it asking us to find? The diameter. So on our circle, the radius is halfway, right? So if the radius is 11 and I extend that all the way across my circle, how long is that whole diameter going to be? 22. Diameter equals 22 meters. Awesome. Okay. Cool. Okay, we got one last problem. I'm going to do it on the back of this. Maybe. Okay. Last problem, application real world scenario. Okay. So let's say that we have, what number is this? 1, 2, 3, 4. This is number 6. Okay. So let's say that we are going to paint the deck on the back of our house. Okay. The deck is this shape. This is our deck. It's really cool. It's all the rage. Everybody wants one. Pretend that line is straight. We have a 14 feet up here. We got 24 feet probably running along the house right here. We got 18, 18, and then they've already told us the height here is 16.5. Okay, so this is our deck. We are going to paint this deck. Okay, and we are going to put 2 coats. Paint the deck with 2 coats of paint. So that means you're going to paint it once, you're going to let it dry, you're going to paint the whole thing again. Okay? So what we know is that 1 can of paint, oops, that's Cam. Sorry. Shout out to Cameron. He's not listening. 1 can equals 72 square feet. Okay? So how many cans of paint will we need to buy in order to paint all of our deck twice? That's the question. How many cans will it take? Okay, so in order to find that, we need to know how big this deck is. So what am I coloring in? What does this represent? This represents the area. So the area of our trapezoid is half base 1 plus base 2 times height. All right, so where are the 2 bases? Bases are parallel to each other. Okay, so that's going to be half of 14 feet plus 24 feet. The height is the part that makes the right angle. So that's this thing right here, 16.5. And that's going to give us the area. Okay, so I'm going to go to my calculator and I'm going to do 0.5 parenthesis 14 plus 24 times 16.5. So the area of my deck is 313.5 feet squared, or square feet. How many cans of paint will we need to use? King really wants to know. There are these cats that keep walking in front of our house. He's going crazy. Okay, so 1 can of paint is 72. How many times will 72 go into 313? So 313.5 divided by 72. 313.5 divided by 72. So that's roughly 4.35 times, right? So this is how many cans we need, 14.35. So if I go to Home Depot and say, I need 4.35 cans of paint, they're going to look at me like I'm crazy, right? how many cans of paint am I going to need to buy in order to fully paint this deck twice? Yep, I have to round up to 5 cans. If I only buy 4 cans, I will have part of my deck that is unpainted, right? So always round up in this scenario. Okay? Awesome. Great job. Oh, there's my